Now that we have a better idea of limits, we'll talk about what happens for limits at infinity. So first, what exactly does this mean? We're looking to try to figure out what happens if x grows without bound. So the idea is, what's exactly happening at the far ends of our graph? And we denote it like this. The limit as x goes to infinity of f of x. And we'll say this is equal to L. It is very possible this doesn't exist, but if it exists, we'll say L. So let's look at some examples. Here we have a graph of a function, and we want to know what happens as x approaches infinity. So we're trying to see what's going to happen as we keep going. This dotted line I have driven here is x equal to 2, and you can see this graph is getting closer and closer and closer to the dotted line. So we're going to say the limit of this graph is 2. What about the limit as x approaches infinity of e to the negative x? Well, now it's important to kind of think about what the graph looks like. The graph of e to the negative x looks like this. And we can see as we go further and further out, we're going to get closer and closer and closer to 0. So the limit as x goes to infinity of e to the negative x is 0. The next one, the limit as x goes to infinity of e to the x. Once again, it's a lot easier with these if we think about what the graph looks like. And the graph of e to the x looks something like this. And we can see that this thing just keeps going up forever, so the limit here is going to be infinity. If we want to look at the limit as x goes to infinity of sine, well, we can think what the sine graph looks like. And it's just going to oscillate back and forth forever. So this one does not exist because as we move further and further and further to the right, we don't actually reach a number, we just continue to oscillate. Now let's look at the limit as x approaches infinity of x cosine squared x. And this graph is a little strange because essentially cosine squared is going to keep us positive all the time, but as x gets bigger, this thing gets taller and taller. So in this case, once again, our limit does not exist because we don't approach a single number. Instead, we're going to be oscillating indefinitely. And while all of my examples looked as the limit goes to infinity, this works the same way if you want to look at the limit as x approaches negative infinity as well.